Miss Hammarlund science class. Today we will be learning about, what are we learning about today? Thanks for the introduction, I guess. Today we will be learning about volcanoes. Since you have already invited yourself to this lesson, why don't you help out? Volcanoes, huh? I've always wondered why they form. To understand that, we need to talk about plate tectonics. Underneath the Earth's crust, there are many large plates that glide over Earth's lithosphere. Right beneath our feet, 8 major plates, and some smaller ones, are moving at about the same speed as fingernail growth. What the plates do affect us. When 2 plates move away from each other, that's called a divergent boundary. Not divergent. Those movies suck. That is completely besides the point. Divergent boundaries can cause rifts and ridges. The next type of boundary is a transform boundary, which occurs when 2 plates grind against one another. This causes earthquakes. The last type of boundary, a convergent boundary, gives us the answer to your question. When one or both of the colliding plates are oceanic, this causes a subduction zone. The denser of the 2 plates is forced under the less dense one, causing volcano formation. The forcibly subducted rock melts and turns into magma, which eventually finds its way through cracks in the surface. Say, is the Pacific Ring of Fire one of these subduction zones? That area is packed with lava spewers. On the Ring of Fire, there are many subduction zones. Many oceanic plates are colliding into continental plates and are being forcefully submerged. Because of all of the collisions, a whopping 75% of all active volcanoes are in the Ring of Fire. Also, 90% of all earthquakes occur in the Ring of Fire. That is quite the tectonic rage. Is that also a hotspot? Not exactly. A hotspot is, hey, put your phone away. I don't mean that kind of hotspot. A geological hotspot is a volcanic region that is fed by especially hot parts of the Earth's mantle. This type of volcanic activity is unique because it does not occur on plate boundaries. The most well-known hotspot is in Hawaii, where hotspots and plate movement cause volcanic change to form. Oh, okay. Can you do me a favor and grab my tablet for a second? I have some photos I need you to pull up.
1 minute, 37 seconds later.
Now, let's talk about the different types of volcanoes and the anatomy of them. First, we have a cinder cone volcano. This is the most common type. They are steep, cone-shaped volcanoes made up of volcanic debris. So, like Sunset Crater in Arizona? Yuppers! Shield volcanoes are broad, domed volcanoes that have sloping sides. The lava that flows from shield volcanoes is typically fluid and basaltic. So, like Mauna Kea in Hawaii. You know your volcanoes, girl! Composite volcanoes, or stratovolcanoes, are cone-shaped volcanoes that are made of many layers of pyroclastic material, which we will talk more about shortly. Lava from these volcanoes is thick and viscous and tends to cool quickly. Isn't Mount Vesuvius in Italy a composite volcano? You know it!
Moments later.
What about necks and pipes? Volcanic pipes form as the result of deep origin volcanoes having violent eruptions. They are composed of a deep, almost carrot-shaped cone of solidified magma. These are relatively rare. A volcanic neck is a column of igneous rock that was formed in a volcanic vent. Magma has hardened into the vents of these remnant volcanoes. These are volcanic landforms rather than typical volcanoes. Does that make sense? Yeah. I have another question. You mentioned pyroclastic materials a little while ago. What is that? If it's just volcanic material, then isn't it just igneous rocks? There is more released during a volcanic eruption than just lava. There are 4 kinds of pyroclastic materials. First is volcanic bombs. They are large bombs of magma that harden in the air. Lapilli are pebble-like bits of magma that harden before hitting the ground. Volcanic ash forms when gases and stiff magma expands rapidly, and the walls of these gas bubbles explode into tiny glass-like silvers. Finally, volcanic blocks are pieces of solid rock erupted from a volcano. Alright, cool. No pun intended, I guess. I've been meaning to ask what determines the intensity of eruptions. Why are some eruptions capable of destroying civilizations while others barely do a thing? There are a few factors that determine the magnitude of eruptions. The main ones are the composition of the magma and gas content. For example, if the magma is composed of mostly basalt, the eruption will be gentle because basalt has low viscosity and is low in gas content. However, magma containing high amounts of rhyolite is very viscous and has high gas content. As the magma moves into the vent and pressure drops, the trapped gas wants to escape. So the magma is sticky and resists the expansion of gas bubbles, and ultimately enough bubbles grow and expand to blow the magma into fragments the size of ash and eject them violently into the atmosphere. Okay, that makes sense. Awesome! Jenny, I have a question for you. Can you name 2 notable volcanic eruptions? No, I have this one. One eruption was the eruption of Mount Vesuvius that destroyed Pompeii. Another one was the eruption of Mount St. Helens in Washington. That eruption killed 57 people directly, and more ended up dying as a result of smoke inhalation. Hey, she asked me! Thank you for your answer, Tammy, but next time can you please not blurt out? Alright, fine, sorry. And look at me, losing track of the time again. Have a great day, everyone. I love you all.
You suck.